Hi class, we have the second lesson for mensuration, but the previous lesson one was all about parts of a circle. Yes, so we are starting circles actually. We have different cases of mensuration, but I want us to start with circle. So let's see the formulas we have in circle. First of all, for a circle, here is a circle. Yes, for this circle, here is the center. From the center of the circle to any part on the circumference, that is radius. Yes, that is radius. So if we are to write the area of a circle, the area of a circle is what? Is pi r squared. Pi r squared. Now let me tell you this. In circle, we have what we call area, we have perimeter, we have circumference. Yes, circumference. I hope it is clear. Okay. But perimeter and circumference, they are just the same. The only thing, circumference is only for what? Specifically for circle. So we also have what we call length. Yes, the length. The area, the template for the area is theta over 360 times pi r squared. I hope it is clear. And the template for, okay, this is just the same. Perimeter and circumference. The template here is theta over, okay, let me forget about the perimeter. Let's talk about the length. The template for the length is theta over 360 times 2 pi r. Please do not forget this. Only when area is mentioned, you think of r squared. When area is not mentioned, don't think of r squared. Now you will see how we'll be using this. Now, what is the area of a circle? The area of a circle, since we are dealing with area, it's supposed to have been this one, theta over 360 times 2 pi r. But this theta over 360 times 2 pi r, that's, sorry, times pi r square, because we are dealing with square, sorry, area, so think of r squared, not 2. This area of a circle we want to write that's supposed to be derived from the template here. But a circle now, a circle has what? 360. So this theta is replaced by 360. So this will take away this. So the reason we have pi r squared. I hope it is clear. Just follow, you'll be seeing anyone that comes with area, how we involve this one. This is the template for area for circle. This is the template for length of whether it's a circumference or whether it is an arc. All right, so area of a circle is pi r squared, because for a circle, the full circle has a degree of what? 360. You divide it by the template 360 here, this and this will go away, leaving pi r squared. So this is area of a circle. So for a circle, how about the circumference of a circle? Circumference of a circle. What about circumference of a circle? Now we are talking about the distance that goes around the circle. So we are here. This is the template. When it comes to length, when it comes to area, this is the template. So now let's determine the circumference of a circle, which is from theta over 360 times 2 pi r. But since we are dealing with circle, so the full circle has a degree of how many degrees? 360 degrees over 360 degrees times 2 pi r. So this and this will go away, leaving what? 2 pi r. So circumference of a circle is 2 pi r. The key point here is for a circle, once we mention area, this is a template. We mention length, this is the template. So if you are discussing area, circle, for a circle, the amount of degrees is what? 360. So 360 over this 360 will go away, leaving this one. The reason we have this as what? Area of a circle. Now, when it comes to the length again, you substitute this theta was 360. Why 360? Because a full circle has 360 degrees. So this is what we have. Now, how about semicircle? How about semicircle? Look at the semicircle here. Look at the center. With this center, oh, okay, we can accept it this way. Now, look at the center. We have the diameter that divides the circle into two equal halves. So if you take away this half, what remains? It remains what? Half of a circle. Half of a circle is what we call semicircle. So for semicircle, what is the area? Semicircle, what is the area? So if we want to know the area of a semicircle, we don't need to go to the template again because for a full circle, the area is pi r squared. So if this one is semicircle, which is half of a circle, if this one is a semicircle, which is half of a circle, and for a full circle, the area is this. So area of half of a circle, it means half times pi r squared. Pi r squared, which is equal to this times this is what? Pi r squared over 2. Or if you want, you can simply write half pi r squared. This, they are just the same. So you don't need to go to the template again because full circle, the area is this. Semicircle is just half of this. But what if you want to see how we still get it there? No problem. A full circle is having 360 degrees. But because this one is half, we consider what? We consider 180 degrees. So theta is 180 over 360 times pi r squared. 0, 0 goes 18, 1, 18, 2. So half pi r squared. You still get this one. Half pi r squared. So this is the formula for area of a semicircle. So now semicircle, we don't discuss circumference. Semicircle, what do we discuss? We discuss perimeter because this is not a curve. Yes. So we say perimeter. For semicircle perimeter, well, you need to understand first what we mean by perimeter. Perimeter and circumference, they are just the same. The only difference is that circumference is reserved only for circle. But circumference means the distance that goes around the circle. So generally, perimeter means the distance that go around the shape. So if you want to know the perimeter of this semicircle, it means we need this distance, we need this distance. So what is this distance? Diameter. What is this distance? Is arc. So for us to get the perimeter of a semicircle, what we do is length of an arc over what? Sorry, length of an arc plus diameter. So what is length of an arc now? Length of an arc, we are discussing length. Look at the formula here. Theta over 360. I hope you are with me. 360 times 2 pi r. What is this? This is the length of an arc. But perimeter means the total distance of a particular shape. So if this one is the length of an arc, how about this one? Diameter. But diameter is obtained when this radius and this radius are combined. Meaning diameter means a radius plus another radius. That gives us diameter. So now we can say plus the diameter. Diameter is 2 times the radius. You write this one, you are perfectly okay. But the thing is, since we are discussing semicircle, of which we know the amount of degrees here, which is 180, if we replace this by 180, what do you think? 180 into 360 is 2. 2 takes away 2. What remains? It remains pi r. So we can say pi r plus 2r. This is the formula for what? Perimeter of a semicircle. Pi r plus 2r. I hope it is clear. I don't just want to be writing this. I want you to understand how we get it so you don't forget. Do not forget what I mentioned earlier. Only in area you think of r squared. When it is about length, there is no r squared. I hope this one is clear. So circle, semicircle. Let's go another one that is highly related, which is what? Quadrant. Quadrant. But we need to identify first what a quadrant is. Qua is talking about four. Qua, quadrilateral, quadrilateral, quadrant. Look at the circle here. Here is the center. If this circle is divided into 4 parts, center is this. The circle is divided into 4 parts. One of the 4 options is what we mean by quadrant. Look at it. This is the quadrant. This is the quadrant. So for this quadrant, what is the area? We are discussing area. We go from there. Do not forget, we go from there. That is theta over 360 times 2 pi r. Theta over 360 times what? 2 pi r. But quadrant now is 1/4 of a circle. If a whole circle has 360 degrees and we have 4 equal portions, it means this is going to be 90 degrees. So do not forget that quadrant has 90 degrees angle. So this theta becomes 90 degrees. 0, 0. 9 is 1, 9 is 4. 2, 1, 2, 2. So we have 1 over 2, 1 over 2. Oh, sorry, we are talking of area. Area is pi r squared. There is not like 2 there. So you see, when you have concept already, even if you want to mistake, you know. We want to talk about area, we'll go to that. Theta over 360 pi r squared. So well, because of quadrant has 90, so we say 90 over 360 times pi r squared. This goes, here is 1, here is 2. So 4, sorry. So we say 1/4 pi r squared. The area of a quadrant is 1/4 pi r squared. I hope it is clear. If you want, you don't go to that, you go here. Area of a full circle is pi r squared. So if you need a quadrant, which you know that it is 1/4 of a circle, you can just say, well, 1/4 of this one, pi r squared. But I just want to emphasize that everything about circle, the area, this is the template. Everything about circle, the length, this is the template. So now you know how everything has been given to us in mensuration for circle. Now we are done with what? The area. Now we are going for what? The perimeter. Perimeter of what? Perimeter of a quadrant. Perimeter of a quadrant. But perimeter means the distance that goes around the shape. This is not the quadrant. Look at the quadrant. That is the quadrant. Perimeter means the distance that goes around what? The shape. I hope it is clear. Now, how do we determine the perimeter of a quadrant so that we don't memorize it? Well, we have what? We have arc, length of arc. We have arc, we have radius here, plus r, we have radius here, plus r. So this will give you the formula for perimeter of a quadrant. But how about length of arc? Length of arc, look at the template here. Theta over 360 times 2 pi r plus r is 2r. But because you know that for quadrant, the angle is exactly 90 degrees, this theta is replaced by 90. 0 goes with 0. 9 is 1, 9 is 4. 2 is 1, 2 is 2. So half pi r plus 2r. You don't need to memorize anything here because everything you can do it. Perimeter of any shape is the total distance that make up the shape. Why it's only about circle, we use the word circumference, the total distance that goes around what the circle. I hope it is clear. Okay, so this is the formula for perimeter of a quadrant. So we are done with circle. What again? Semicircle and quadrants. So let's go for something else. Okay, so let's go for sector. But we need to understand first what a sector is. Here is the center. This is a radius. This is a radius. We have an arc. This one is an arc. And it makes an angle. The angle it makes in mensuration, we see what it subtends an angle. You see, the arc subtends an angle at the center. What does that mean? Subtends an angle, meaning the ends of the arc they meet at the center to form an angle. To say all that grammar, we say the arc subtends an angle, meaning the angle and the arc forms an angle at the center. So this space that is formed by the arc and the two radii is what we mean by sector. I hope it is clear. But the question I want to ask you here is, don't you think that this sector resembles the quadrant we previously discussed? Well, this tells you that the quadrant is also a sector. Why? Because it has the attribute of a sector. A sector is a space formed by an arc and two radii. Any space that is formed by an arc and two radii is a sector. But why this one is having a unique name, quadrant? Because it is 1/4 of a circle. Equal. When a circle is divided into four halves, four equal portions, one portion is what we call what a quadrant. So that is the reason it has a unique name, quadrant, and it has 90 degrees. Does this one have 90 degrees except otherwise? Sector is a general name. Quadrant is specific for the one with 90 degrees. But this is a sector, even quadrant is a sector. But this sector is not a quadrant unless if it has 90, it will be called that one. So now let's see now. Let's start with area. Area of a sector. What is the area of a sector? We are discussing area here. Huh? What is area of a sector? We say theta over 360 times pi r square. This is just the formula for area of a sector. So it's surprising to understand that the template I have been mentioning happens to be the area of a sector. Why? Because the sector we are talking about here is not specifying an angle. It does not talk about specific angle, so it means this is the area. But what if the sector is a quadrant with 90? Well, this cannot be the formula because you can replace the theta with 90 degrees and everything will become 1/4 pi r squared. But the fact that we are not having a specific angle, the template remains the formula for area of a sector. Is that understood? Good. Now let's go to what? Perimeter of the sector. Perimeter of the sector. Perimeter is about distance that goes around the shape. Yes, which is this length, arc. So first of all, we talk about the arc length. Arc length plus r is 2r. So what is arc length? Look at the template for arc length. Theta over 360 times 2 pi r plus 2r. If we are talking of quadrant with a specific angle, we replace theta. But sector is having theta, which stands for general angle. So this one remains the formula for perimeter of a sector. This is the formula for perimeter of a sector. I hope it is clear. Okay. So we are done with sector as well. So how about from this point to this point? From this point to this point, it is what? It is arc. So if you want to know the arc length, look at the general formula. Theta over 360 times 2 pi r. But the end here and the end here can meet at the center to form an angle. So we can say the arc subtends an angle. Our concern here is not the space, it's just the arc length. So the fact that we are not referring to a specific angle, so we allow this one to be the formula for arc length or length of an arc. I hope it is clear. So can we talk about perimeter here? No, because we are not referring to the space. We are referring to what? The length of the arc only. Our concern is not the space formed. Our concern is the arc length. So length, we don't have anything like perimeter of the length. No. Okay. Now we have what we call segments. Here is the center. Okay. Here is the center. Now what is segment? Segment is formed by a chord and an arc. Arc and chord. This space that is formed is what we mean by segment. The space formed by an arc and a chord is what we mean by segment. But this segment is a space. So we have the area, we have the perimeter. Let's start with the area. How do we get the area? First of all, the ends of the arc can subtend an angle here, generally theta. So since we are referring to area, let's go to that case. So we say theta over 360 times pi r squared. I want you to pay attention. Area of a segment is what we want. Okay, let me remove this. Let's say we have this arc, this end. So they meet here to form this angle. The space formed by a chord and an arc is segment. The space formed by an arc and two radii is sector. But area of sector is this one, which is theta over 360 by r squared. But our concern is only to find the area of the segment. So the only way we can get the area of the segment is for us to have a chord like this. We remove this triangle. If we remove the triangle, we have only the segment. That is why the formula for area of the segment says area of sector minus area of the triangle. Area of segment is equal to area of sector minus area of triangle. What is the formula for area of sector? It is this one here. Theta over 360 times pi r squared. What about area of triangle? Area of triangle, we have three formulas for area of a triangle. We have three formulas for area of triangle. Yeah, we have, if we have the base and the perpendicular height, we have this formula. Yes, if we have only the three sides, where we deal with what? Hero's formula. Then we have another one that says if we have AB and the angle, we have that formula. So this one is half times base times height. This one is the root of s into s minus a, s minus b, s minus c, where s is half of a plus b plus c. Is that clear? But what if we have two sides and the included angle? Well, we say half a times b is ab sine theta. So which of these three formulas we are dealing with here for triangle? Let's see which one we have here. Well, from the center to the radius is r. From the center to the radius is r. So you can see that we have the angle, we have r, we have r. Look at it. The angle, we have r, we have r. This is the formula we use, which is half AB sine theta. But our AB here is just r and r. So meaning this A is r, this B is also r. So what is r times r? R times r is r squared. So this one gives us the area for what? Of a segment, which is area of a sector minus area of a triangle. Because if you have a whole sector and remove what the triangle, what will remain? The segments. So this is it. Let's go for perimeter. Perimeter of what? A sector. What makes up the sector? The arc plus what? The chord. Oh yes, chord. Yes, the arc plus the chord. So what is the formula for length of an arc? I wanted to even forget length of chord. Yes, what is the formula for length of an arc? Length is this one, which is theta over 360 times 2 pi r plus length of chord. Length of chord is 2r sine theta over 2. This is the formula for length of chord. I would have forgotten the formula for length of chord. So let's go for length of chord. How do we get the formula for length of chord? I know the examiner may not ask you to derive all of these ones, but I'm just explaining so that you reduce the level of memorizing them. Okay. Now look at the circle with a center. Here is a chord. We want to find its length. Now let's join this and join this. Okay. Here is what? Theta. But we know from the center to the circumference is r. The center to the circumference is r. So we want to find the length of the chord. What do we do? Let's take that one out so we can see it clear. R is theta. A triangle with two sides equal is called what? An isosceles triangle. If a line comes between the two equal sides, that line makes this one 90 degrees. And it divides this angle into two equal halves. So if the whole of this angle is theta, this angle becomes theta over 2. This angle becomes theta over 2. What do I mean by theta over 2? I mean half theta. Yes, you have one piece of chalk. You divide it equally. You have half piece of chalk, half a piece of chalk. You have a whole theta. You divide it halfway. Half theta, half theta. So R, theta over 2, theta over 2. So what do we do? Let's just focus one side. So let's find what is here. Let us call it X. But don't forget that this line divides this line equally. So whatsoever we have here is the same thing we have here. If here is X, here again is X. So finding this triangle X is the same as finding this X. So let us use this one here, or we can use this one here, just the same. So this side is opposite to theta upon 2. This R is the hypotenuse because of the right angle here. So opposite over hypotenuse is sine. So we say sine theta. What is the angle here? Theta over 2. See, sine of an angle is equal to opposite over the hypotenuse. I hope you get it. Sine of an angle is opposite over the hypotenuse. So what do? We give this 1. 1 times x is x. Sine theta upon 2 times r is r sine theta upon 2. Do you see that? So that tells you that here is x, which is this one. But don't forget that this and this combined gives us the chord. So for us to get length of chord, what do? We say this x plus this x to give us a full length of the chord. So what do we say? We say x times x plus x is 2x. So 2 times x. What is x? R sine theta over 2. So combining them, we have 2r sine theta over 2. So that is the formula for length of a chord. So for us to get the perimeter of a segment, and for a segment is the combination of an arc and what? A chord, this one. So length of an arc is this, length of chord is this. So this one gives the formula for what? Perimeter of a segment. So this is what I have for the second lesson. Thanks for watching. Don't forget to follow, like, share, and comment.